So the topic of today's talk is industrial IoT wireless networks. So during our 15 years of experience, we've kind of looked into what is the important factors for our customers when designing this type of network. And we have ended up with 6 different topics or features that we see are important for the customers. So we have the coverage or the range of the wireless network. We have the battery lifetime of the network, the reliability, security of the network, but also the fact that you can make it get to the market quick and yet build intelligent systems. And it has to be future-proof. So the customer has to know that the network he has now will always also be a good solution for tomorrow. So I'll go a bit through these 6 features to explain a bit why these are important. The coverage and the range is important in a wireless sensor network, but it all depends on the use cases that you have. Some sensors are like body-worn sensors. That means the range is not important. If you want to communicate from your heartbeat sensor to your mobile phone, it's 30 centimeters. So in that case, the range is not important. But if you're tracking containers worldwide, range suddenly becomes coverage becomes very, very important. So in our use cases, we think more of the industrial use cases. And that for us means it's in a factory, it's in a commercial building, a school, on a campus. So it is limited in area, but still not in like in a few meters range. But here it all comes down to the application. So that means there are no one solution that fits all. You have to look at the application. But if you consider industrial use case, we see that like a 200-meter indoor is a very good range measurement, and that is a practical range of actually 4,000-meter outdoor line of sight, which is the best equivalent we can do. That means that for these cases, 2.4 gigahertz is not an option. Because you have to have numerous repeaters or numerous gateway to cover these industrial use cases. Battery lifetime is also critical, but also this basically comes from the feature of using low current consumption. And that low current consumption you can kind of benefit from in several different ways. Either you could say that, okay, I use lower power consumption than other wireless networks. That means I can change the battery every 10 years instead of every year, and that will give you a less maintenance cost. Or you can say, I will still change the battery every year, but I will simply report my sensor every 10 seconds instead of every 5 minutes. That can give you other operational benefits to know quicker when something happened in your buildings or in your systems. Or you can actually also say that I will simply use smaller batteries, so reducing cost and reducing size of your products. But it all comes down to using less current. So the technology has made some leaps there over the last year. So there are very good technology out there now that you should be able to take advantage of. Reliability is also something which we see is a core for many of our customers. That means that in all radio communication, you will lose RF packets. That's kind of the nature of wireless. You lose radio packets. So that means that you have to ensure that the packet comes through anyway. And the most natural and common way to do this is actually by having an acknowledgement scheme and retransmission. And a lot of the radio technologies out there today does not actually include that. So these low power WAN technologies like Sigfox and LoRa do not have an acknowledgement of all packets. So they are good for their use cases, but in case you need to be 100% sure that a message is gone through, they are not that suited. Frequency hopping is another method which can increase reliability, because if there are noise on a specific frequency, you will retransmit on another one. It's also important to have reliability on the downlink, because if you want to set some information, set an actuator, and do this kind of things in a IoT system, you want to make sure that that message is coming through. An important feature which we also see in reliability is that both sides need to know if a link has gone down. So in case there are some noise, something has happened to the system so that the link is down, you want to make sure that not only the sensor discovers it, but also that the gateway discovers this. And this is normally done by having heartbeat function. So that means the sensors sends regular message just to say that I'm alive, and that will the gateway should monitor this and know when devices are lost. Security is a very hot topic within the wireless IoT, and becoming much more, the customers are becoming much more aware of this. So there are several features you want to include in your security scheme. One is the access control. You want to make sure that only devices that you allow in the network joins the network. You want to ensure privacy. That means nobody can listen to your devices. That means you have encryption on the lower level, but also on the application layer. So that means you can have end-to-end encryption, so that the gateway, which could be an insecure element, is not able to read the data. You want to make sure that all the packets you receive are authenticated. So typically you want to have a message authentication code. And you want to make sure that you have protection against replay attacks, meaning that somebody wants to destroy your network could listen to your network and then simply repeat the message. So this is all security mechanisms that you should think of including in your system. So short time to market. In the IoT world, everything moves quickly. So a good idea now might not be a good idea in 2 years, because there are 10 new competitors out there which already introduced the system. So you want to make sure when you come up with a good idea, have a good product idea, that you get the solution out there quickly. That's also important from a sales perspective, to get feedback from your customers that this is the product that we search for, so you can make any changes. So getting the product out there is important to make money, and you use your windows of opportunity. So it should be easy to create products with this. It should be easy to create interfaces to different sensors and actuators. It should be easy to change the behavior, program the behavior of each device. And it should be easy to do deployment or commissioning of the system and verifying that the system works. This is something you also should look for. So even though it's easy, it should still be intelligent and smart. And this is sometimes looked at as a contradiction, because if they're very easy to use, that means they're kind of dumb. But it's important to also have a system which enables you to do smart processing in the sensors. So that means you don't want to send all the data from the sensors up towards the cloud, because simply it might overload the cloud and stuff like that. So you want to be able to do what's called mist computing, or computing at the outer edge of your network, to do smart decision, to do machine learning and stuff out on the end nodes. And also you want to be able to do computing at the gateway, or what's called fog computing, to be able to do smart decisions there and not wait for the long loop towards the cloud. But still, you want to make sure that you also have an easy cloud integration, because the data or the information that you extract from your system after you've done local processing needs to be taken up to the cloud to be integrated with other systems. So it's important to look at all these features and make sure that you have a system which allows this. And then it's about future-proof. It's important that you don't make a system today and find out tomorrow it's obsolete. So you want to make sure that you have that you base it on open standard with a lot of different with standards which are supported by a lot of different hardware suppliers. You want to make sure that you have OTA, over-the-air capabilities, because your features or your behavior today might not be what is suited tomorrow. So you want to make sure that you can upgrade this. So this is for us the 6 different features, which is the most important, we see as the most important features to think about when you design a wireless sensor network for IoT applications. So I do have a challenge for the audience, and that is, what features are the most important to you? It could be one of the ones we mentioned, or it could be something else. So if you have any features that you feel is important, please post them in your top priority features in the chat window, so we can get some feedback on that. With that, I will leave the microphone to Eugene Peng, who will talk more in detail about our solution to this set of features that we now have put up there. So please take over, Eugene.
Thank you, Ørjan, and hello everybody. My name is Eugene Peng, Senior Firmware Designer at Radiocrafts here in Norway. So, given some of the features that Ørjan talked about, the team here, we've been thinking a lot about how to approach a solution, provide a solution that makes it really easy for you and our customers to get started on a IoT wireless system that is low power, that's reliable, that has the necessary coverage, secure, and what we find is that because IoT is becoming more complex, you need a whole system to make it possible. So what we come up with is RIIoT, the Radiocrafts industrial IoT solution. It's a complete RF system that you can integrate with any sensors and actuator, and to a gateway where you can connect your data into the cloud or whichever backend server you want your application to be on. So in this presentation, I will give you an overview of the features and comparisons with different technologies. And in this slide, I'll just start with some overview of the platform. So you can connect several hundred nodes in the network. It's a starred network, so it's a simple point-to-point for low power. And you can, what you will have is an SPR module, which you can use on the end node to integrate with sensors and actuators. And for this module, you don't need a different coprocessor. You can program right on the module with event-driven application framework and SDK that we will be providing. This is it has a high reliability RF connectivity with a medium-long RF range. It's based on a sub-gigahertz 802.15.4 GE standard that has been out for several years now, and it's been deployed for millions of units already. So it's a mature open standard. And it has you can have two-way communication and two-way reliability, high level of security. And we provide also a software package for Linux gateways. It's called the RIIoT Network Controller. Also with the coprocessor modem called GPR module that you can integrate with your gateway, and to also make it easier for you to connect to your cloud. And we also added an extension to the 802.15.4 that allows you to do over-the-air update. And the whole system is really optimized for low power for any battery operated systems. Yeah, and I can see in the chat window, yeah, some comments about long battery life and over-the-air update. Great, and we get a lot of questions about how it compares with different technologies. There's so many different competing technologies now, and it's hard to sort of know what is the right one for your application. So here we put together a table to compare the different technologies out there on the market. There's a lot of data here, but what I want to focus on, there's sort of two categories we're trying to compare here. One is the range, and the other one is the reliability factors. So if you're first looking at the range, you'll see RIIoT at the standard 50 kilobit per second. It gives 380 meters in the metal factory. We also offer a lower bit rate, lower bit rate that extends the range to 720 meters or 1.5 kilometers on high power. Now, this is not competing with the LoRaWAN Sigfox, which is in the multi-kilometer wide area networks. You can also see on the how it compares with the wireless M-Bus, 280 meters at 868 megahertz or 2.5 kilometers at 169 megahertz. And Zigbee and BOE, they're much more for personal area networks. So it's not in the same area that we're targeting. Now, if you're looking at reliability, there's sort of three different ways you can measure reliability, or three different ways interference can come from. It can come in the time domain. So if your signal length is very long, it makes it easier for it to be interfered in the time domain. It might conflict with other signals. Interference could come from the frequency domain, and so the more narrow the bandwidth, the more reliable your network is. The interference can also come from just noise signal. So it's like what is the noise strength you can tolerate? And also sort of on the standard MAC layer and application layer, whether you have acknowledgement and retry schemes. So what we show here is we designed the RIIoT system to have either good or medium I guess features in comparison to all the reliability factors. If you first look at the second column, the signal length, if we take a 12 byte signal at RIIoT at 5 kilobit per second, it takes 45 milliseconds. At 50 kilobit per second, it takes 4.5 milliseconds. If you look at LoRaWAN or Sigfox, it could take over a second to send the signal, which makes it a lot easier to be interfered with. And if you look at the next column, the receive bandwidth, the RIIoT is at 49 kilohertz with 98 kilohertz, while the LoRaWAN Sigfox are 125 and 30 respectively. But if you look at Zigbee and BOE, they're much higher bandwidth. We also offer option for frequency hopping, which is also needed in the US. That also helps to protect reliability. And the next column, the interference tolerance, and you also see it's the RIIoT is at -129 and -120, which is comparable to the other standards. And finally, the acknowledgement and retry schemes is offered to offer additional protection, and this happens on both ways bidirectionally, which is not what you wouldn't see in LoRaWAN and Sigfox. And I know it's a lot of data here, but you could come back, and it's also on our website. You can come back and look at this data on your own time as well. So next we move to comparing the power consumption, and this is one of the things we're really trying to optimize because we hear a lot from our customers about the long battery life, especially for wireless sensor networks that needs to operate for many years. So its battery life is determined by, so one factor that determines it is the time in transmission. So here again, we look at the signal length, and you'll see that because the RIIoT RF on AOT.15.4 uses much less signal length, you're looking at 45 or 4.5 millisecond compared to the LoRaWAN and Sigfox, it will use less current. And you can also look at the typical RIIoT current for transmission. It's at 26 milliamps, which is also low. And there's that column for the energy per packet, which is just the signal length multiplied by the transmission current. But what does that actually mean? So the next two columns we're looking at, okay, given how much energy it takes, how fast can your sensor update? So we took a benchmark that the sensor has to last for 5 years on a coin cell battery at 500 milliamp per hour. On the RIIoT 5 kilobit per second, it takes you can report data every 1 minute and 42 seconds. On the 50 kilobit per second, you can report data at every 10 seconds. But on the LoRaWAN and Sigfox, you're looking at 1 hour and 2 hours. So RIIoT gives you, if you have an application where you need more periodic monitoring, RIIoT offers that. And the next column, number of packets, and it's just given the update rate, how many total packets you can send in 5 years. And at the bottom, you can see the typical RIIoT currents for transmission, 26.5 milliamps at 14 dBm. And at receive is at 6.2 milliamps. And a sleep current of 0.2 microamps. And a shutdown current of 0.185 microamps. Okay, next we're looking at this event-driven application framework that we're offering for you to develop your own intelligence on the end nodes, whether you want to interface to a sensor or an actuator. And we really try to provide a framework with an API where we extract a lot of the complexity in the hardware and the RF network to provide a simplified interface where you can write a complete application in less than 100 lines of a high-level C code. But if you want to add more complex intelligence, there is a 8 kilobyte memory also available for you to write more complex edge intelligence. And some of the modules available are timers for you to create periodic or one-shot timers, non-volatile memory for data logging, different interfaces, UART, I2C, SPI, GPIO, ADC to connect to whatever sensors or actuators or other serial buses. And also, of course, all the APIs to manage the RF network, to start a network, to send and receive messages. So you see, you can, with this, you wouldn't need another processor. You can write all the intelligence onto this one module. And next, I just want to show you, give you a sample of how the API looks. On the right side is an example code to set up an application with I2C, GPIO, and periodic timers. Yeah, you can take a look at how it's simple, it's easy to read. It allows you to register event handlers. So it's event-driven. In this case, you can see it's initializing I2C to 400 kilohertz. You're initializing a GPIO pin to be an input, and to detect when there's a falling edge, to trigger, and you can pass in your function called send data. So then whenever the button is pressed, you can trigger this function to send data. And there's a line to create a timer that's periodic timer that happens every 30 seconds. We can read the sensor. Yeah, so the whole framework is easy and event driven, and it's sort of based on if this and that. while underneath that, the framework really takes care of managing, monitoring the network and all the complexity. So you don't have to be an expert on a specific hardware platform. You don't have to be an expert on the RF networking. Great. And the next slide, we're looking at what we offer to help you to ease with the gateway and cloud integration. So if you're using a Linux gateway, we offer a package called RIIoT Net Controller. It's a middleware service that helps to interface your gateway application to the RF network. It talks with the GPR coprocessor modem, and it simplifies all the RF networking, and it opens up a socket API that your application can connect to, and uses a simple JSON commands for you to configure and communicate on the network. The socket and JSON is designed so that you can write your gateway application in any language that you want, giving you the flexibility to choose how you to integrate even with your existing application. And the RIIoT Net Controller also, it helps to translate binary data from RF, which is more efficient for power. It translates it into JSON data model that your application can then map it to different cloud services. Okay. Security. On the RF networking, we're using AES-128 CCM. It's an authenticated encryption scheme to provide confidentiality, integrity, and authenticity for your data on the network. Protects against eavesdropping, modification, replay, and impersonations. On the MAC layer, all the nodes share the same key, but as well on the application layer, we're also implementing. There's a unique key established between every node and the gateway, so that even if one node is compromised, your data on the network is still protected. Optionally, for applications where security is more important, you can choose an end-to-end encryption, where the encryption encryption and decryption is only possible between the end node and your application on the cloud. So your data is protected all the way from the node to the cloud, and protected against any vulnerability, even on the gateway and all the in-betweens. And we also provide whitelist access control. You can specify the list of known nodes that you approve, and only these nodes will be accepted to join the network. So we come to an overview of the full package. So the package, the system includes 3 different components. One is the RC1880X SBR, software programmable RF module. You can program your own application on top of it. It's based on the 802.15.4 sub-gigahertz RF protocol, low power star networking, AES-128 encryption, operates on 862 or 932 megahertz with option for frequency hopping, message acknowledgement and retries, an option if you want longer range, up to 8 kilometers is the 5 kilobit per second. You can use it for bidirectional, so you can, for sensors or actuators. It has a compact RF module. It's the same size as our standard module. The max output power 14 dBm, ultra low power, sleep. You can see interfaces with SPI, I2C, ADC, UART, and GPIO, and up to 8K code space if you want to implement more complex intelligence. So that's for the end nodes. And on the gateway side, we provide a RC1880X GPR module. It works with the RIIoT Net Controller in the Linux gateways. if you have a non-Linux gateway, you can also access it directly. It has an UART protocol. So the RIIoT controller, yeah, it's a Linux middleware that we'll be providing. It helps you to support the setting up and configuring the RF network. It monitors the network for broken links. It has a socket API with JSON data. It manages the over-the-air update, and it's given to you as an executable binary. And to really accelerate your development, we have a suite of tools. We have the SPR SDK that helps you to develop your application for the end nodes. It comes with the application framework, API, and compiler. There's a free IDE that's based on the popular Atom editor, Flash programmer, and example codes and tutorials to get you started really quickly. And there's the RIIoT RF development kit with all the hardware pieces to get you started. There's the SPR sensor board, which has the SPR module on it, as well as a few sensors for temperature, humidity, accelerometer, light sensor with examples, so you can start testing right away. And there's a GPR development board. Again, allow you to connect to your PC, and has allows you to start connecting to your gateway or to a PC to get started. And also an RF link test tool, so if you want to test the RF performance in your environment. There's a software package, the RIIoT controller, which I already previously mentioned. It also comes with example user applications and cloud integrations. And also a RIIoT network dashboard, which is a Linux application that interfaces to the RIIoT controller. It provides a browser GUI to help you to visualize the network data and manage the network. And you can use that during development and testing of your network. So that's all the tools. So as a summary, sort of coming back to the factors we were considering at the beginning of the presentation that we think is really important for the industrial wireless: coverage, range, battery lifetime, reliability, security, short time to market, yet intelligent and smart, and also it's future-proof. We do the best we can to offer RIIoT as a solution to cover all these points. So I think if you're developing industrial IoT wireless solution, and I think RIIoT is something we highly recommend for you to consider. So that comes to the end of our presentation. Ørjan, do you have anything to add?
No, so thank you, Eugene. Now we are over to the Q&A part. So I thought I should go through a couple of comments already in the list, and feel free to ask any other questions there. I see that you mentioned that update over the air is good, but not if you need to send a person there, and that's completely from Jacek, and that's completely correct. But the whole idea here is that you don't send a person there. You actually, since this is an IoT solution, then you that means that you send the firmware from a central point from the cloud and distribute it. So that's the whole idea. You should not send persons there. So also the long battery lifetime and is important, which we all agree. 380 inputs, so we do have support for ADCs and several channels. Temperature humidity sensing, we typically see that going more towards digital sensors nowadays, but of course it's also possible to do, and we do also have examples of that already on the sensor board, so that's for sure. Easy smartphone app development is also something we're looking into. So here for Ilka, it's I guess the question is also if you want to how the connection to the cloud to the smartphone is being done, because you have the options to do it over through the cloud, which is then not something we would be involved in. Or we do have on the roadmap also modules, dual modes module will also have BLE connections. So that's something which are coming, but it's not something we will release now. But that's also something we're looking at. But normally we see people making cloud connections through to the apps. 169 is currently not supported. This is for 868 and 915 megahertz. The reason for that is 169 typically offer very low data rate and very long range. So 169, we do have our product supporting 169, both the wireless M-Bus and the RC232. But because low data rate, it's not. We do think that the solutions we have there is what is already good solutions for 169. So I would recommend, in case you need a longer range than the RIIoT can offer, we do have the 1701 products, HP products, which is suitable for that solution today. Yeah, the guidance for license compliance. That's a good question, but so we do have some FAQ or question answer on the web on that for the different modules. This RIIoT will be offered, as Eugene mentioned, at 868 megahertz for CE compliance, which will cover Europe and several parts of the world. And we also offer it on 915 with frequency hopping, for which we plan to do FCC certifications on, so it will be compliant to that. Compared with our price, APK asked for. So price is of course comparable with others. I'm not sure what others, if you mean other other suppliers, but it will be in the comparable to our other products. It will be a lower cost than 169, but it will be. So I think we will have a good price point when we release it, but yeah, I'm not sure what are the others. It's difficult to say, but it will not be $1, but it will be certainly sub $10. Some BLE would be interesting. Yes, so BLE is as I mentioned on the roadmap, but it's not in the first release. I can also mention that so the current status of the product is that we are now supporting. We have a package which is ready where we support alpha customers. So that means that given that the customers have the right project for this, we do support him now, and we plan a full market release for all customers. In the end of Q3, which we are entering now. So I don't see any other open questions at the moment. So if there are no more questions, I will thank you for listening to us. There were a lot of details today, so in case you need to go through it, the webinar will be online, and we also have put information on the RIIoT products on our web, so you will be able to find more information there as well. And if there are any other open questions, please don't hesitate to contact us. So thank you very much for listening, and have a nice day and a good weekend.
Yes, thank you so much, Ørjan. Thank you so much, everyone who was listening today. And this webinar will be available on our website, and also I will send you the direct link so you can watch it again anytime. And yeah, feel free to share this webinar with your colleagues, with your teams, and share this message. And we are looking forward to have more insights from you guys. Thank you.